Alrighty, hopefully everyone's paying attention at this current moment in time so I can go, class. Where are you on that one, Denny? No, no, Sue. No, Sue. Anyway, alright, so we're going to finish up our notes for Chapter 2, Section 1. And, okay, so the derivative, if you guys remember what the generic terminology for it is that it is the slope at a singular point. So finding the equation of a slope at a singular point. And usually it's just going to be like a position. So we've been given different types of interpretations, geometric. So if we take a look at it, we have a graph. You look at a single point, and then it's the slope of the tangent at that point. Rate of change. Okay, so we have like finding the velocity at a single point as we're traveling, because if we're going, as Denny's driving through that school zone, okay, all the elementary kids that is bobbing and weaving away from his vehicle, okay, so those kids, so as he's driving, he puts his foot on the gas. He's not doing 60 miles an hour the whole time, right? You can get up to 60 miles an hour, but you started at 0, right? So at a single point, when you hit that kid, we're trying to figure out the speed at that time, okay? You eventually got to 60, but not when you hit that kid, right? Okay. All right, so just so you know, this is going to be Examine A, okay, Exhibit A in the murder trial, okay, yeah. All right, and physical interpretation. When the distance s at time of t of an object in rectilinear motion is given by the function. That's what we did with the throwing the rock off the bridge. Okay, find the derivative of this at x equals 8. Now, I'm going to rewrite this. Are you waving at somebody? Hey, no one wants to watch you eat Pop-Tarts. Anyway, so I'm going to rewrite this, and it's going to make my math a whole lot easier. So if I rewrite this function, knowing that exponents and roots are basically the same thing, it's just written slightly different. So it's 2x raised to the 1/2. Right? That's a square root. Yes, I have another one. Did you lose yours? And yours? Still look for it? And another one? Sure? Looks like it. The last one. I don't know, you tell me what. Alright, so are you guys okay with what I did right there? Square root is now the 1/2, right? Yep, power of a root. And a square root is 1/2, okay? So what I could do is I could rewrite this, and I'm going to. So I'm going to rewrite it again, but this time, since both the x and the 2 is inside there, watch this. I'm going to go 2 to the 1/2 times x to the 1/2. Yeah, it's basic algebra. Everything's being raised to that power, right? So it means the same thing. Now, let's go to what we did on Friday. That crazy rule, the witchcraft, the voodoo, to take a derivative. What do I do with the exponent? Multiply it out the front, right? Yeah. Okay, so I take it and multiply it out front. So it's going to be this 2 to the 1/2 times 1/2, right?
Yeah.
And then what do I do with my variable? What do I do with the exponent over the variable? What do I do with that? What did I supposed to do with it? There's something I do to the exponent also. You can look at the notes from Friday, right? What did I do with the exponent?
Oh yeah, -1.
-1, very good. So I'm going to subtract 1 from my exponent. So now, right now it's 1/2, but I'm going to -1, but my 1's going to look weird. I'm going to subtract 2 over 2. Why would I subtract 2 over 2?
It still equals 1.
It's still 1, right? But why did I use 2 over 2 instead of just writing 1?
So it's very easier to subtract.
Why?
You do my.
Thank you, that's what I'm looking for. So common denominator, right? So common denominator is there. Now I can do this. Now everything is now set up. So let's go ahead and multiply the top, not the top, but the front part right here.
Wait, what about the 2 1/2?
I'm still, what? No. Only over the variables.
It's only variables. Okay.
Only variables that you do that to. So now, let's go ahead and put that together. So in the front, it's going to be 2 to the 1/2 divided by 2. Because technically, isn't that 2 to the 1/2 still over 1? 1, isn't it? Yeah? Yeah. Okay. So now let's do my powers. It's going to be times x. What's my exponent going to be? -1/2. So I know this looks kind of crazy right now, but I can clean it up even more. So I can clean it up even more. So now that's going to be a rad 2 over 2 times x to the -1/2. So this is one way to write the answer. The other way, what can I do with negative exponents? Something about the power. What can I do with it? If it's negative, I can move it across the divisor. So I could take it from the numerator and move it to the denominator. And if I take it from the numerator, move it to the denominator, what's going to happen to that negative? It's going to become positive down there, right? So the sign changes. So now this is going to be rad 2 over 2x to the 1/2. So this could also be the correct way to write this. So all that right there is going to be my f prime of x is going to be rad 2 over 2x to the -1/2. Right, and I'm going to erase my work over here so we could do part B. Or actually, do I have another page? No, I don't. Insert page. There we go. My f of x was my f prime of x is rad 2 over 2x to the -1/2, and my coordinate is 8, 4. Use the derivative of f prime at x equals 8. Find the equation of the tangent line to the graph at that point. So, let's go over here. Now, let's figure out what it is going to be when x is 8. So my derivative, So my f prime of 8 is going to be, I'm plugging in, so it's rad 2 over 2, and it's going to be 8 to the negative 1 half. Now it just looks kind of crazy now, right? So this is where I'm going to put that exponent back in the denominator. So I'm just going to rearrange this so hopefully it makes a little bit better sense so you can see this a little bit better. That means the same thing. I took that power of 1/2 and I put it back to square root. I kind of can. There's a couple things I could do. And depending on your factoring skills. So I could factor the denominator, the square root of 8, I could say that's going to be 4 times 2, right? Okay, is 4 a perfect square? Yeah, so 4 is a perfect square. So that means it's going to be left over 2. So if I rewrite this, the square root of 4 is 2. So I'm rewriting again. 2 still on top. And then there's already a 2 out front. There's already a 2 out front. So, and it's 2 times 2, which is going to give me 4 on the outside. And then what's left over on the inside? Square root of 2. Yep, and then I could cancel out my rad 2's, right? All right, is this kind of crazy or losing people now? Not yet? Kind of? Speak now or forever hold your peace. So my f prime of 8 is 1/4. Now, by definition of a derivative, what does that mean? The slope. Slope of the tangent line. Keep going. Slope of the tangent line. Okay, so to this function, right? When?
When the point is 8, 4.
Yes, at 8, 4, the slope of the tangent line, when x is 8, y is 4, at that point, is going to be 1/4. So the slope of the tangent line when x is 8 is going to be 1/4.
Like 1/4.
Nope, 1/4. The slope is 1/4. Is that crazy or is that no? So let me put this back in here now. So that we know that m, which is my slope, is going to be 1/4. So the slope of the tangent line is 1/4 at the point 8, 4. Now can I get the equation of the tangent line? What would I do to find the equation of the tangent line? Point slope. So that would start off with yep. Now, the book likes making you go all the way down and put it into y equals mx plus b. This is a correct answer. So if we're doing the free response test, this is correct answer. But if you need to actually get the slope intercept, I would have to distribute. So that would be 1/4 x minus 2, and then I'm going to plus 4 plus 4. So I get y equals 1/4 x plus 2 is the equation of the tangent line. You guys feel okay with that? Maybe? All right. Last one for this set of notes. Approximating the slope. So this is what we're going to do. We don't have an equation here, so we can't take a derivative. So what we're going to do is we're going to find the slope. I'm going to approximate the slope in between here and here, because I want to figure out what it is going to be at 2. When x is 2, I want to find the slope. So basic formula on slope is y2 minus y1. So it'd be 12 minus 3 over 2 minus 1. And this is the secant slope. Secant is I am touching 2 points of the arc. So the slope of the line that actually touches those 2 points. So let me see, that's going to give you 12 minus 3 is going to be 9 over 1. So the slope of my line in between those 2 points is going to be 9. Positive 9, right? Now let's do it again. Because at the point 2, that doesn't really help me out too much. Let's try 2 to 3. So now from 2 to 3, the secant slope would be 33 minus 12 over 3 minus 2, which is going to give me, is that 21? So if I'm looking at this, no. So it would be from here to here, and then here to here. So it's basically saying this is a slope of 9. This is a slope of 33. Because I'm trying to figure out the slope at that singular point just using the graph. So I have 2 different slopes in between there. So I know that somewhere in between is supposed to be the slope at 2. So what I'm going to do here is I'm going to take an average of those 2. I'm going to take the average of those 2. So let's go ahead. It would be 21 plus 9 divided by 2, which is going to give me 15?
Yeah,
15. So we're going to approximate the slope, and we're going to say it's 15. What else could I have done instead? Say 33 minus 3 over 3 minus 1, which is 30 over 2, which is still gives me 15. So the average slope in between those 2, yeah. So we could average out the slope in between the 2.
Instead of,
Yeah. Sometimes you don't have a value here. you don't have a value here, so you would actually have to use the left side and right side to try and figure it out. Okay? All right, so hopefully that's going to help you out when we, average would be right here, like that. Hopefully that'll help you out with a lot of the homework, with any of the weird stuff on this. All right. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from the merch store.